So the goal for today is to take one of the example applications that ships with Natural One and deploy that onto a runtime in AWS on an EC2 instance. We're going to use a Docker layer to make that happen. In between, I'm also going to discuss some of the reasons that you might want to move to the cloud in follow-on to the previous conversation, and also look at some of the strategies that you might choose, and also try to make the case why this particular strategy might be one that you want to start with or look at. So in case of introductions, my name is Neil Bailey. I've got around bit more than 20 years experience in the IT industry nowadays. I work for AWS, so I'm predominantly focused on AWS technology and the deployment of AWS services and technology on top of AWS, often in an automated fashion, often as infrastructure as code, and I go and work with our customers to help them do that. It often brings me very close to complementary services, things like Docker, things like Natural, things like Adabas, and other things that our customers are working with. You can see down the bottom, so I've spent a few years working as a Java and TypeScript developer and Python developer. Interestingly, you can see there's no Natural up there, so if you have any Natural questions, I'm definitely not the person to ask, so stay away from that. And if you can't tell from my accent, I'm from Scotland, so I brought Nessie with me just to represent my home turf. Within AWS, I work for AWS Professional Services, or we could say AWS ProServe for short. The main goal of ProServe is to work hand in hand very closely with our customers and use our experience from other engagements, working with other customers, to accelerate those customers in their outcomes that they're trying to achieve. So it could be things like cloud migration, for example. And in the last way of introduction, I'd like to introduce slightly the relationship between AWS and Software AG. So Software AG are AWS ISV, or Independent Software Vendor Partner, and they have a number of accreditations with us in that space. However, they also work very closely with AWS ProServe when delivering for and with our customers. As we mentioned earlier, we are working currently in the UK for a large public sector organisation where we're trying to help them solve a few of their challenges around their aspiration for migration. The diagram on the right kind of highlights some of the talking points about the things that we're helping them with and helping them through. So for example, how will we migrate data from on-premise into the cloud? How will that physically happen? What will the runtime look like once they move their applications and databases into AWS? What will the developer experience look like? And how can we make sure that everyone's comfortable, that they can develop and add value, and the application will have a future? And also, how will the end users connect? What will their experience be like? So these are some common questions that customers may have, and jointly, as a combined team, we're working with Software AG, the customer, and ourselves to kind of solve these problems. So, what I'm going to do first, I think I've had enough talk, so I'm going to get in and start building something. So what we're going to do today is deploy an instance, an EC2 instance in AWS that is going to host the Natural and Adabas in containers. I've already got deployed a Natural One instance that's running on Windows, and I'm going to build an RDP into that box. I'm going to use Natural One CE today, just for simplicity, and then I'm going to deploy the example application onto the newly deployed box. And we can see how it can be a relatively easy thing to do. So this is the AWS console. Anyone used AWS here before? Let's just show of hands. Yeah, fair few not. So let's see. So I may go through a few terms. We probably don't have time to get into everything today. So if you find me after, you can dive deeper on a few things. So EC2 is our instance-based compute platform. So if I click into there, ooh. And you can see I have one running instance currently, which is my Natural One C instance. It's passed all its checks, it's healthy. And actually, if I go into it, I can RDP into it, right? So this is a standard RDP session. So it's running in AWS, but it looks no different from a local Windows desktop. I've pre-installed, as I said, Natural One CE, and we'll come back to that later. Everything's booting, everything's fine. While today I'm using RDP, there are different delivery methods that you could use if you wanted to choose to run Natural One in the cloud. We have a service called AWS AppStream that allows you to stream the user experience into a web browser, which could be quite a useful and portable way for developers to connect and use the application. But for today, we'll just stick with RDP. So we're going to build out the Linux box. I'm going to launch a new instance. And I'm going to call it ANN, Adabas and Natural. You can see that we support obviously lots of different types of instance. So today we're going to use a Linux instance with Amazon Linux. You could choose Red Hat or SUSE, something if you wanted. In terms of the instance size, I'm going to use an M5 large, which has got 2 vCPU and 8 RAM. In terms of if you wanted to do this yourself, pick whichever fits your budget and your performance requirements, right? So you'd have to do some right sizing to figure out what was going to work for you. I can also pre-provision an SSH key pair onto the box, so when it boots, if I want to connect into that box with SSH later, I already have a key on there and I can connect into it. From a networking perspective, I already have a VPC, which is a networking construct in AWS deployed, and the Natural One CE instance is in that same network construct. So what I'm going to do is deploy this new box together in the same availability zone as the Natural One box, so the two can talk together. But what I need to do is place them in what we call a security group, and I'm putting them into the same security group in this instance, such that the two boxes are not only co-located from a network perspective, but they also have permissions to talk to each other, which is going to be important. Another thing I want to do, as I talked about putting an SSH key onto the box, if I wanted to use SSH, we also have out-of-band connectivity that we can provide through a service called Session Manager. So what I'm going to do is give this instance the privileges to be able to connect to Session Manager so that I can connect it from an out-of-band perspective to finish the installation later. Now, all these settings would give us a vanilla Linux box, but what we want to do is pre-provision some of the services that we're going to use today onto the box. And the way we do that with EC2 is through the use of user data. So user data is an input field where we can put data that can be ran one time on install or every time on boot. So we're going to make use of this today to install some components, as I say, that we're going to use for the rest of the demo. Now, I do have a script prepared to help us do that. So there is some boilerplate that you can see here that's required from a user data script perspective. I'll skip over that today again. It would probably take a while to go into the detail. Primarily, there are 2 or 3 other main sections. So the first one is we're going to install Docker and configure the Docker engine to start. The next things we're going to do is pull down the container images. So regarding the container images themselves, Software AG have done a really good job of publishing images that you can get used to get started onto Docker Hub. And you guys can go out and pull those. They're publicly available. In production, obviously, you may consider building your own images and making them more portable in that way. So that would be a good way to go. The rest of this here is basically I'm going to create a startup script on the box, and I'm going to go into that startup script later and execute it. It's a little bit difficult to read here because I'm creating the file, so I'll look at this later and go into it in a little bit more detail. So that being done, we are ready to launch the instance. And you can see the ANN instance is running, but it's currently initializing. So while it's initializing, this will take a few minutes. I'm going to cut back to the presentation, and we'll go through some other detail and come back to this. So as I saw show of hands earlier, a few people using AWS, a few people not. So I thought I'd start with the basics. What is cloud? What is AWS? So AWS is nothing more than the on-demand delivery of IT resources with a pay-as-you-go pricing model. It's pretty simple. The pricing model I'll come back to on a following slide. In terms of the IT resources themselves, they're nothing that's alien to you to start with. So we have CPU, we have RAM, we have storage, we have networking, and various flavors of each of those that you can consume. On top of that, though, we have what we'd call AWS managed services. So AWS managed services are typically where we will take away some of the undifferentiated heavy lifting from configuring and managing services in the cloud. So an example of this could be our EKS, or Elastic Kubernetes service, where we take away the undifferentiated heavy lifting of configuring the management and control plane of a Kubernetes service. So that allows you just to consume that Kubernetes platform through an API where you don't have to worry about standing it up or managing the nodes. It's all done for you. So that's an example of an AWS managed service. And often, the more managed services you can consume, the more you can free up your resources within your organization to focus on other things, meaningful things like adding value to your applications. So, why AWS? Why cloud? Why get into it in the first place? So I did say I'd come back to the pricing, so I'll start with cost reduction. Often cost is the first reason customers start to talk to me. It can be driven when they're facing a renewal on their existing hardware, be it mainframe, or it could be a VMware estate or any type of hardware estate that's on-premise. It could be that renewal they're facing is for their existing capacity, or perhaps they want to expand capacity and are facing additional costs for that. So often, again, cost is one of the initial conversations we have. The interesting thing, I did say it's pay-as-you-go. So one thing to be aware of, it changes particularly a CapEx model from the past into an OpEx model. So if you don't really bring your finance people and your finance teams with you when you're endeavoring upon this, you might find it difficult to get funding, difficult to secure your budgets for cloud migration journey. The other interesting thing about pricing is the transparency that you get from cloud and the transparency you get from AWS. So we produce what we call a cost and usage report that gives you fine-grained detail around how you're using your instances, your networking, your APIs, and allows you to apportion cost. And all of this gives you a high degree of runtime cost transparency that then you can use to pass on to your engineers, architects, DevOps guys, developers, so that everyone's making cost-aware decisions about how they're going to run their architecture. It's often a new element to people's jobs, and often people haven't considered that in the past, so it's another thing to consider. Moving on to risk mitigation. So I think the technical debt and the aging components, I think they're fairly self-explanatory, right? Maybe you made choices 10, 20 years ago that you wish you hadn't, and you find it difficult to move because you've got hardware in place, services are running. Skill shortages was covered yesterday, so I think we talked about that at length. So what I'd like to focus on from a risk perspective is these siloed teams. So what I often see today with large enterprise is you've got the people working on-prem or with mainframe, and then you've perhaps got people working in cloud. And often the two don't talk, and that can cause problems with organizations because anytime you've got a large communication boundary or large silos, things just move slowly, very difficult to change, and very difficult to protect the future of the application ultimately with these types of silos. Often the people in the cloud are looking back at the people on-prem, and they're saying, oh, I wish I was these guys. Look, they've got all their ITIL process, their change control. Things are fantastic for them. They can use their full platform. They don't ever get asked, why are you using this new service? Things are easy for them. And then you get the people that are on-prem looking up to the people in cloud and going, why does everyone talk about these guys? Why are these guys getting the funding? So, it works both ways. And so my thinking here is moving the applications from mainframe or on-prem into the cloud, really try to break down those silos and work as a multifaceted team to approach the problem. So while these two are good, I think the most exciting thing for me is the increased agility that cloud brings. And hopefully through the demo today, you'll see it's quite easy to experiment. So experimentation is a good thing. What you should be willing to do is experiment and fail. That's the way we learn, right? So cloud enables us to do that because of its costing model and because the capacity is there on demand. We can choose to try things, and if it doesn't work, no harm, we can move on. All of this elastic on-demand capacity comes through the fact that we have APIs for everything in AWS. All our services are fully supported by APIs. We produce SDKs for all the popular programming languages to allow developers to get started quickly and easily in consuming the services. And all this pervasive automation and APIs really lends itself well to a strong base to build a DevOps and CI/CD capacity on top of. Altogether, I guess, again, back to my main point, I think it's a really good platform for innovation and trying new things. However, it doesn't mean you have to leave behind the things that you've already created and invested a lot of time into. In terms of general approach, as the pictures sort of suggest, so you've got your sort of current situation, everything on the mainframe, over on the right, everything's in blue, nothing's changing. Often, without knowing and without making a conscious decision, enterprises will move into the second row here, which is augmented or hybrid, where you've still got your stuff running on the mainframe, but maybe now you build out a new React or Angular-based front end and it starts running in the cloud. As was discussed in the previous presentation, some of the challenges here are really about networking. If you're going to run that augmented or hybrid operating model, you need to make sure that your networking is going to be solid and it's going to be able to support it. And often as well, this kind of naturally lends itself to the silos that I was suggesting earlier, probably something you want to try and break down. So those are some of the concerns of that operating model. However, I do see it as probably one of the first ways that people endeavor into cloud and get started. Over on the other side, we've got refactor. So refactor or rewrite. So in this case, you're building your whole application from the ground up. Maybe you pick a different operating system. Maybe you pick on a new cloud. Maybe you're going to use a modern programming language. Maybe you're going to use a new database technology. And that's fine. I think the good part is that you're ready to go and you're fully modernized by the end of it, right? But the risks here are if you go into this without fully assessing it, you might never get there, right? It is going to be a big undertaking. And also, you're not taking anyone with you. So all the experience you had of the people that know how to manage the data and know the history of the application are not getting pulled through. So you're kind of leaving something on the table that you perhaps want to make use of, really, in terms of human resource and technical capability. Last thing on this one, if you try to do it manually, which a lot of people will, I would suggest that you're not going to get there, right? So if you are going to do this at all, you really want to be looking at automated tools to kind of help you get there. And finally, if I go to the middle one, which is kind of more lending itself to the demo from today, this is basically putting in a mainframe compatible middle layer, so Docker in this case. The benefits here is you can largely keep most of your application code, and you can largely keep your data intact, and you're just migrating the application code and then migrating the data. The benefits here, everyone knows, perhaps understands the code base, they know and understand the data and the data format, and then you can reuse a lot of that human skills and human resources that people have built up over time. It's potentially the lowest risk as well, right? Because you've got an application that runs and you're just moving it into a different place and it runs just the same, so perhaps low risk. And I'm going to suggest perhaps one of the lowest cost and lowest time durations as well, so in this middle column. You'll notice the blue boxes are not entirely blue, so I don't want to say that you will, without doubt, move 100% of your code. You may have to tinker on the fringes, but I think this would be areas where you're interacting with external components and external dependencies. So for example, if you were reading from a message queue, you may want to change how that's done in the interface, for example, right? So there may be a little bit of massaging around the edges of your application. But we should go into this approach optimistic and hope that it will work. In terms of the tech stack, so we've seen this kind of diagram in terms of the tech stack a few times over the last few days, where we've got Adabas and Natural running on Linux. Linux, of course, can be Dockerized, and we can run it on containers. And once we've got something that can run in a container, then we've really got a really strongly isolated packet of abstraction that we can run on any compute platform we choose. So today, in the demo, I'm showing you EC2, which is our Elastic Cloud Compute, which is our instance-based compute option. I talked earlier about EKS, which is our managed Kubernetes service that could also be used to run the container. AWS Lambda is our serverless architecture, and that can also more recently run containers. So that may be useful if you wanted to run a very short-lived processing job in response to an event or something like that, right? So ultimately, there are a number of other compute platforms that you could choose to run the container on. So it gives you a wide variety of flexibility to pick the right one for the right job. So hopefully, the other thing around the silos is once you containerize, it's just another container. So you're going to have people, no doubt, within your organization that work day to day with containers. Maybe they have a Kubernetes platform, maybe they have an OpenShift platform, whatever. But ultimately, they'll know how to work with and manage the deployment, the patching, the availability, the build of containers. And moving into this world will allow you to leverage their skills to assist you in the migration, right? So it's just another container, no different. Again, this kind of democratizes the access, because once you get it into cloud, into AWS, there's a lot of other people in your organization that will be interested to help you then, right? And to help you get started with how do I integrate logging, how do I integrate security, what about my compliance guardrails, how do I put those in place? And you can leverage other people's skills. You don't need to do all this on your own. Around the innovation piece, this is quite a disposable way. So you can try something, throw it away. If you try Kubernetes and it doesn't work for you, then you could maybe switch to ECS, which is another container management platform in AWS. Try a few different options, see which one works. And ultimately, I've talked about picking the correct compute platform, but the other thing, as you saw earlier, there's also an adjustment in scale. So you can adjust the CPU, RAM, storage, networking for the particular compute platform as well to tune it to your performance needs. So at this point, I'll go back to the build, and we'll see if everything's done its thing. The moment of truth. So you can see our Adabas in natural instance now. It has no alarms, and it's fully healthy. I'm going to connect it using Sessions Manager. Again, this is an out-of-band connection, so no true IP connectivity. It's a very secure way to do it. Everything through the session can be logged as well for security and monitoring. And I'm just going to switch user to EC2 user, which is the user that I used to create the startup script. You can see the startup script that I created has been rendered. And as you can see, it's a little bit easier to read it here than perhaps it would have been before. The main commands to look at are the two Docker commands, right? So we're starting an Adabas container, we're starting a natural container. We can pass in flags to the pre-built container image to do things like, for example, accepting the EULA, configuring the IP address of the Adabas instance from the natural instance's perspective, and connecting the two together. Over on the right, for both of these commands, you'll see we're using the two images that were previously downloaded from Docker Hub. So just to prove there is no containers running just now, so Docker PS, no containers running, everything is fresh. If I run this script, it'll spin up the containers for us. And you can see there's two containers started 1 or 2 seconds ago. Typically, because I like to make sure things are working, check again. Yeah, they're still up. Everything's good. The development manager is running on port 2700. The only thing else I'm going to need is the IP address of this instance, and then I can connect to it. So if I go back to the console, go back into the instance, I can get the private IP address here, so I can just copy that one. And then I go into Natural One and edit the runtime. And you can see I'm on the correct port, 2700. And also, just to show I was listening, top tip from yesterday, I enabled logging, so we should see some connectivity going on here. There we go. So we're uploading the code to the box, updating it, and then we can run the application. All going well. There we go. I can't just resist to say hello, SAG user group. Oh, thanks. And you can see the communication to and from the server, right? So everything is working. I can stop sweating now. Right, so moving back to the presentation. Hopefully, yeah, hopefully you can see it's quite an easy thing to do, right? So the kind of innovation that you could drive off the back of this, it's just a starting point, but it'd be a way to wet your feet. So, yeah, so what I'd like to talk about is, okay, this was a demo, where does it fit in? Where's it potentially useful, right? So this is quite a complicated diagram, and I'm not going to get into it, but it's complicated for a reason, to show you that ultimately the full ecosystem will be complicated, right? It's not going to be a simple thing. People generally want to analyze, develop, build, test, and deploy into production or multiple other environments. You might have multiple teams or multiple pairs, perhaps programming to develop multiple features. And you might still have parts still in the mainframe, so you might have different teams still working over there. So how does it all come together? As has been previously mentioned on other sessions, Git is a good way to do this and synchronize code between the existing mainframe into the cloud. Most of your modern developers, as soon as you put the code into Git, they'll say, fantastic, I can work with this now. So that's a really good first step. Across the top here, the area I won't go into is a number of AWS products that allow you to create pipelines, to do deployments, builds, testing. And yeah, we'd probably need to do a separate session on that, but ultimately they're going to support these different steps that you can see in the horizontal lines. From a production perspective, yeah, if you're going to deploy containers, you probably want to use some kind of a platform to do that on, like EKS that's purpose-built. And you may have multiple production, non-production, or test or QA environments. The demo I did today, though, I think it fits in right down here, right? So when you're doing early development and when you first take that code off the mainframe, what you're going to really want is something you can say, well, how do I start? Can I start this? Is it going to boot? Is it going to run? And you don't really want to worry about how you're going to build your final production architecture at that point, right? We've already seen there's a lot of options around clustering, storage, networking, hybrid connectivity, right? So there's a lot of things to consider before we get into production. But the demo that I just showed really has its place sort of down here when you're trying to experiment. And it's very disposable. I can throw away these containers. I can start again 2 minutes later in a fresh system. So it's a really good place to use technology like I've shown in the demo. Additionally, I think you can see the little flywheel, right? So initially when people take the code off the mainframe, again, they're going to be interested to, can it run? And what am I going to have to refactor? I talked about that small percentage that you might have to change. So there's going to be a little flywheel here where people are currently going through deploying, testing, trying to make that application run. And again, a containerized runtime, like we've just seen, is an entirely reasonable place to start. Main thing, don't worry about the end, start at the beginning, right? That's kind of the recommendation. So the next steps, so the demo we've done today, we've ran jointly with Software AG as what we at AWS call an immersion day. So an immersion day is where we go out to our customers, we sit with them in a training room, and we really get hands-on with technology. So we'll go through something like the demo, but doing it perhaps at a greater depth. For those that you were paying attention, I did start up the Adabas container, but the Hello World didn't really touch the sides of Adabas, right? So, perhaps an immersion day is a place that we could start to get into that a little bit further. If any of you would like the code sample, find me, reach out to me, give me your email address, I can share that across, and that'll allow you to start the instances, no problem. And as was already previously mentioned, there's a number of blogs that have been published. I've just pulled out one from one of my colleagues at AWS that's available on our website that could let you get started. Okay, so thanks everyone. I hope you enjoyed the demo.